industry.
So before we dive into the nitty-gritty of the job, I'm curious, what's the biggest misconception people have about mechanical supervisors?
I think a lot of people assume that it's all about technical know-how.
Okay.
But in reality, it's just as much about leadership. You're not just fixing machines.
Right.
You're leading a team in a high-pressure, high-stakes environment where safety is paramount.
Absolutely.
It's about quick thinking, clear communication, being able to make tough decisions under pressure. And honestly, a lot of that comes from learning by observing experienced colleagues and navigating real-world challenges.
It sounds like trial by fire.
Yeah. Oh.
But in a good way.
Yeah, a good way.
Okay, so let's paint a picture for our listener.
Okay.
Imagine stepping into a typical day as a mechanical supervisor in a bustling oil refinery.
Yeah.
What's on the agenda?
Well, every day is different, but there are some constants,
Okay.
You'll start by reviewing your job description.
Got it.
Planning the day's workload, which involves prioritizing tasks and figuring out who needs to be where.
Right, so it's almost like
It's like a giant chess game.
There you go.
But instead of pawns and bishops, you're moving welders and pipe fitters around a massive refinery.
And the board itself is pretty complex, right?
Oh, yeah.
We're talking about huge distillation columns, intricate pipe networks, maybe even those monstrous steam boilers.
Exactly. You're overseeing the maintenance and operation of all this critical equipment. One minute, you might be troubleshooting a faulty pump. The next, you're coordinating a major repair on a heat exchanger.
So this all sounds incredibly technical.
Yeah.
What are some of the must-have skills for a mechanical supervisor when it comes to the actual equipment?
Yeah, so you definitely need a solid understanding of static equipment like pressure vessels and boilers, plus piping systems, and how they all connect. Being able to read and interpret technical drawings is essential, as is the ability to make those crucial repair-replace decisions.
Oh, wow.
You need to know when a quick fix will do and when you need to bring in the big guns for a complete overhaul.
I see. And this is where all that on-the-job experience really comes into play, right?
Absolutely. There's a certain intuition you develop over time. You start to recognize patterns, anticipate problems, and develop a feel for how different pieces of equipment behave under various conditions.
Speaking of conditions, let's talk about something that's top of mind in a refinery.
Safety.
This video really hammered home the idea that a mechanical supervisor isn't just responsible for getting things fixed.
Right.
They're directly responsible for people's lives.
Right, one wrong move could have devastating consequences. That's why the world of refinery safety revolves around permits.
Okay.
Each task, whether it's a simple repair or a complex welding job, requires a specific permit. It's like a system of checks and balances to make sure every precaution is taken.
So it's not just about knowing how to fix a leaky pipe.
Right.
It's about knowing which permit you need to even touch that pipe in the first place.
Exactly.
And from what I saw in the video, there's a whole rainbow of these permits.
There is. You've got your green cold work permits for tasks that don't involve any sparks.
Got it.
But fire up a welding torch and you're going to need a red hot work permit.
Wow.
And that's just scratching the surface. You've got permits for working at heights, entering confined spaces, even just digging a hole.
Really?
Each one designed to prevent a specific type of hazard.
It sounds like a mechanical supervisor needs to be fluent in permit language.
Yeah.
To even function in a refinery.
Definitely.
And speaking of hazards, I'm particularly curious about confined spaces. Those always seem like the most nerve-wracking scenarios.
They are. Imagine having to squeeze into a narrow pipeline or the interior of a large vessel. You've got limited ventilation potential for toxic gases and restricted movement.
Oh my goodness.
And that's why the video specifically highlights the importance of having a dedicated attendant stationed outside.
I see.
They monitor the worker inside and are ready to jump in if there's an emergency.
It's like having a lifeline both literally and figuratively.
Yeah.
But before even getting to the permit stage, there's a crucial step, right? The video mentioned something called risk assessments.
Risk assessments are absolutely critical.
Okay.
It's all about identifying potential hazards before any work even begins. It's like playing a mental game of what if to uncover every possible thing that could go wrong and then figuring out how to prevent it.
And then, of course, you've got your trusty PPE, all that personal protective equipment that's become synonymous with refinery work.
Absolutely. We're talking hard hats, safety glasses, gloves, steel-toed boots, and even specialized respirators in certain areas.
Wow.
In a refinery, PPE isn't a suggestion, it's the law, and often the only thing standing between you and a serious injury.
So we've covered the intense responsibility, the technical knowledge and the unwavering focus on safety. But how does someone even break into this role?
Right.
Let's unpack those interview questions the video focuses on.
So from my experience, those interviews are less about textbook answers and more about gauging your practical knowledge. And most importantly, your safety mindset. They want to see if you can think on your feet and apply your knowledge to real-world scenarios. For example, they might ask you to explain the different types of heat exchangers used in a refinery.
Oh, that's a good one. I remember the video touched upon fixed tube sheet, floating tube sheet, and U-tube exchangers. But why so many variations? It seems like it would be simpler to just have one standard design.
It might seem that way, but each type has its own advantages and disadvantages depending on the specific application.
Okay.
Fixed tube sheet exchangers are simpler and cheaper, but cleaning them can be a pain.
Right.
Floating tube sheet exchangers are easier to clean, but they're more complex and expensive to manufacture.
Gotcha.
And then you have U-tube exchangers, which are great for handling thermal expansion, but can be a bit trickier to maintain.
So it's like choosing the right tool for the job.
Yeah.
But on a massive industrial scale.
Exactly, and that's what the interviewers are looking for. Okay. Someone who understands that there's no one-size-fits-all solution in a refinery.
Okay, so you've nailed the heat exchanger explanation. What other curveballs might they throw your way?
Well, they might ask about hydro tests, which are basically pressure tests.
Okay.
To check for leaks in pipes and equipment.
All right, like making sure a vessel can withstand the incredible forces
exactly
it will experience during operation.
A common question might be, how many hydro tests are required for a fixed tube sheet heat exchanger?
Well, let's see if I remember correctly from the video. The answer is 2. A shell test and a tube test.
Right.
But why not a final test like the floating tube sheet exchangers require?
Good catch. That's because the tube bundle in a fixed tube sheet exchanger is well fixed, so there's no need for a final test after those initial shell and tube tests.
So they're not just looking for the right answer.
Right.
They're looking for someone who understands the why behind the answer.
Exactly.
Someone who can actually apply their knowledge rather than just regurgitate facts.
Absolutely. And those questions can get pretty specific. For instance, they might ask about blinding or spading.
Okay, blinding and spading, if my memory serves me correctly, that's all about isolating equipment.
Right.
It's like putting a physical barrier in place to stop the flow of fluids or pressure.
And it's a critical safety procedure, especially during maintenance work. They could ask you about the different types of blinds and spades, or they might even present a hypothetical scenario and ask you to explain how you'd go about blinding a particular piece of equipment.
This is starting to feel like a real interview. What other technical challenges might they throw at a potential mechanical supervisor?
Well, they might ask about hot bolting, which is a specialized technique for tightening bolts on equipment that's still in operation. Or about different types of strainers used in refinery piping systems and why placement is so crucial.
Okay.
Each question is designed to test your practical knowledge.
Got it.
And how you'd handle a real-world situation.
It sounds like these interviews are as much about problem solving as they are about technical expertise.
Exactly. And that's just the tip of the iceberg.
Oh, no.
In the next part of our deep dive, we'll explore even more of these interview questions and get into some of the more specialized knowledge that a mechanical supervisor needs to succeed.
Stay tuned, folks. We're just getting warmed up. Welcome back to the deep dive. We're picking up right where we left off, exploring what it takes to be a mechanical supervisor in the oil and gas industry.
That's right.
Before the break, we were really in the hot seat tackling those tricky interview questions.
Oh, yeah. Those questions are not just about showcasing your knowledge.
Right.
They're designed to assess your ability to apply that knowledge in real-world scenarios.
Right. Like that question about the number of gaskets needed for different types of heat exchangers. It really highlighted the importance of understanding the why behind design choices. Speaking of which, what's another question that tests that deeper understanding?
Well, they might throw you a curveball like this. What is the function of a floating head in a heat exchanger?
Floating heads, okay, I'm racking my brain here.
Yeah.
They're designed to accommodate thermal expansion, right?
Think about it. In a fixed tube sheet exchanger, both ends of the tube bundle are rigidly attached to the shell. But in a floating head exchanger, one end is free to move. This allows the tube bundle to expand or contract with temperature changes.
Right.
Without putting stress on the shell or the tubes themselves.
So it's like a built-in safety valve preventing those temperature swings from causing damage.
Precisely, and that's what the interviewers want to hear. That you understand the practical implications of these design features.
Okay.
These exchangers operate at extreme temperatures, and even small variations can create significant stress. The floating head helps mitigate that stress,
Right.
ensuring the exchanger runs smoothly and safely.
It really highlights the interconnectedness of everything in a refinery. One small design feature can have a huge impact on overall safety and efficiency.
Absolutely. And speaking of interconnectedness,
Yes.
let's talk about another vital piece of the refinery puzzle: pumps.
Pumps. Those are the unsung heroes of the industry, moving fluids around, like the circulatory system of a giant mechanical beast.
Yeah.
What kind of questions might they ask about pumps?
Well, they could start with something seemingly simple like, what is the function of a pump casing?
The casing, that's the outer shell that encloses all the internal components, right? It's like the protective armor of the pump?
That's one way to look at it, but the casing does more than just protect the delicate innards of the pump.
Okay.
It also contains the pressure generated by the pump, preventing fluids from spraying out uncontrollably.
Oh, that would definitely create a mess, not to mention a safety hazard.
Exactly. And on top of that, the casing provides structural support for the pump's internal components, keeping everything in alignment. It's like the foundation of a house,
I see.
ensuring stability for everything built upon it.
So the casing is like the multitasking superhero of the pump world.
Yeah.
It protects, contains, and supports all at the same time.
Exactly.
But I'm guessing there are different types of pumps for different jobs, right?
Absolutely. They might ask you about the difference between a centrifugal pump and a positive displacement pump.
Okay, pump types hit me with the key distinctions.
So centrifugal pumps use a rotating impeller to create centrifugal force, pushing the fluid outward and creating flow. They're your go-to choice for moving large volumes of fluid at relatively low pressures. Think of it like a water sprinkler, spraying water over a wide area.
That makes sense. What about positive displacement pumps? When would you use those?
Positive displacement pumps operate by trapping a fixed volume of fluid and then forcing it into the discharge pipe.
Okay.
They excel at handling higher pressure applications or fluids that are thicker or contain solids. Imagine trying to push molasses through a pipe.
Oh, wow.
That's where a positive displacement pump shines.
So if you need to move something thick or chunky, a positive displacement pump is your best bet.
Right.
And I'm guessing the interviewers might go even deeper, asking about specific types like reciprocating pumps or rotary pumps.
They certainly could. It's all about demonstrating a well-rounded understanding of pump technology.
Yeah.
And knowing which type is best suited for a particular job.
It sounds like they're really trying to separate the pump enthusiasts from the true pump experts. Okay, before we get too deep into the world of pumps, let's shift gears and talk about another essential part of refinery operations. Piping systems.
Piping systems. Those intricate networks that connect everything in a refinery, like the veins and arteries of a living organism.
They seem pretty straightforward at first glance, just pipes carrying fluids from point A to point B. But what kind of interview questions would test a deeper understanding of these systems?
Well, they might ask something like, what is the purpose of a pipe support?
Now, that seems pretty self-explanatory.
Yeah.
Supports hold up the pipes, right? I mean, they can't just float in midair.
True. But it's not just about preventing sag. Pipe supports also play a critical role in controlling vibration, absorbing shock loads.
Oh, I see.
And accommodating thermal expansion. Remember, these pipes carry fluids at extreme temperatures and pressures.
Right.
Even small movements can cause stress and potentially lead to leaks or even ruptures.
So pipe supports are like the unsung heroes of the refinery, silently working to maintain the integrity of the entire system. And I imagine there's a science to choosing the right type of support for a given pipe.
Absolutely. There are clamps, hangers, saddles, and various other types of supports.
Wow.
Each designed for specific load capacities, pipe sizes, and operating conditions. A mechanical supervisor needs to know which support is best suited for a given situation.
It's fascinating how every element of a refinery, from the massive vessels to the seemingly mundane pipe supports, plays a crucial role in the overall operation. It's like a giant interconnected puzzle where every piece has to fit perfectly.
That's a great analogy. And a skilled mechanical supervisor is someone who can see the big picture while understanding the intricacies of each individual component.
Well, we've definitely covered a lot of ground in this part of our deep dive.
Yeah, we have.
We've explored the challenges of those interview questions, delved into the world of pumps and piping systems, and gained a deeper appreciation for the complexity of a refinery operation.
And in the final part of our deep dive, we'll shift our focus from the technical aspects to the bigger picture.
Okay.
The challenges, rewards, and the future of this vital role in the oil and gas industry.
Stay tuned, folks. We'll be right back. Welcome back to the deep dive. We spent the last two parts really getting into the nuts and bolts of what it takes to be a Mechanical Supervisor in oil and gas.
Yeah, it's been a pretty deep dive so far.
From understanding critical equipment and navigating those tricky interview questions.
Right, exactly.
But I'm also curious about the human side of the job.
Okay.
What are some of the biggest challenges a mechanical supervisor faces on a day-to-day basis?
Well, I mean, think about it. You're working in a refinery surrounded by hazardous materials, operating complex equipment.
Right.
Often under tight deadlines, the stakes are incredibly high, and safety is always the top priority.
That sounds like a pressure cooker.
Yeah.
What kind of personality thrives in that kind of environment?
You need someone who is technically competent, obviously, but also someone who can stay calm under pressure. Right. Think clearly in a crisis and make those split-second decisions. Oh, wow. That could impact the safety of the entire operation.
So it's not just about fixing machines, it's about leadership.
Exactly. You're leading a team of people, each with their own personalities, skill sets, and experiences.
Good.
Being able to motivate them, communicate effectively, and foster a strong safety culture is crucial.
Absolutely.
And let's not forget the constant coordination with other departments, contractors, and even regulatory agencies.
It sounds like a role that requires a unique blend of technical expertise, people skills, and a whole lot of resilience.
It does.
But despite all the challenges, I imagine there are some pretty rewarding aspects to this job.
Absolutely. For starters, you're playing a vital role in a critical industry. The work you do literally helps power the world.
You're keeping the lights on the cars running and the factories humming.
That's a great way to put it. And on a more personal level, it's a job where you get to see the tangible results of your efforts.
Right.
You solve problems, you fix things, you make things work. There's a certain satisfaction that comes from knowing you're keeping those critical systems running safely and efficiently.
And as our expert's own career trajectory shows, being a mechanical supervisor can be a fantastic launching pad for other opportunities within the industry.
That's right. Many mechanical supervisors go on to become planning engineers, project managers, or move into leadership roles in safety or operations. The skills you hone in this position are highly sought after and can open doors to a wide range of career paths.
So let's shift our focus to the future. The oil and gas industry is facing a lot of changes, particularly with the push towards more sustainable energy sources. What does that mean for the role of a mechanical supervisor?
Well, as the industry evolves, so too are the role.
Right.
We're already seeing a greater emphasis on renewable energy systems, carbon capture technologies, and advanced automation.
Right.
A mechanical supervisor of the future might be overseeing the maintenance of wind turbines.
Wow.
Or managing a team of robots inspecting pipelines.
That's a pretty exciting prospect. But even with all these changes on the horizon, some things will always remain essential, right?
Absolutely. The core skills, problem-solving, critical thinking, leadership, and an unwavering commitment to safety, those will always be in demand.
Absolutely.
And as technologies evolve, the ability to learn and adapt will become even more crucial.
It sounds like being a mechanical supervisor both now and in the future.
Yeah.
Is all about embracing challenges, staying curious, and never stopping learning.
Couldn't have said it better myself.
Well, I've certainly covered a lot of ground in this deep dive into the world of mechanical supervisors.
We have.
We've explored the technical demands, the leadership challenges, the importance of safety, and even the potential career paths this role can unlock. But perhaps the biggest takeaway is this. Being a mechanical supervisor is more than just a job.
Right.
It's about taking responsibility, using your skills to solve real-world problems, and contributing to an industry that powers our world.
And for anyone considering this career path, I'd say, go for it. It's a challenging but incredibly rewarding journey.
And on that note, we'll wrap up this episode of The Deep Dive. We hope you enjoyed this deep dive into the world of mechanical supervisors in the oil and gas industry. We encourage you to share your thoughts, your questions, and your own experiences with us on social media or through email. Until next time, keep exploring, keep learning, and keep diving deep into the world of knowledge.